Inviting the speaker and panelists up on the stage. You see that both Georgia Pacific and Ingredion are doing some creative, innovative things, but both Ron and Radek would be the first to admit they didn't do it by themselves. So we're inviting their helpers up on stage, okay? It's Kevin Smith from Canvas and Rajiv Saha from Parabol, okay? We have someone out there with microphones? Emilio, if you could do that. I'm going to ask you to raise your hand. And when you do ask a question, please stand up so we know where you're talking from and give us your name and your company. So questions, raise your hand.
Hello, Susan Messick, Savannah River Nuclear Solutions. And I was just curious to Ron, how did you actually get your operator knowledge transfer into your AI system? Like you're talking about, he knew if the pump sounded like this, what they need to do is about to fail. How did you transfer that into your system?
It's magic. That was the hardest thing. That was the hardest thing. What was your first name again?
Susan.
Susan. Susan, that was the hardest thing. And in the vision that we had, that was why everybody said, there's maybe some people doing this, but most everybody that we talked to said, you guys are nuts. This is not how AI works. But getting that information, first of all, you got to know the right questions to ask, right? And then getting it in. Right now, we haven't taught the machine to listen. So we have to, if we do interviews, then that has to get transcribed into English. And then the machine can read it. And then it creates a knowledge graph. Now, Rajiv is actually the one that built that. So I know there's magic sauce in there someplace, but can you give them a little bit of detail about how you take the knowledge from the person and put it in there such that the machine can use that to go look at the data that it needs?
Right. Nothing is magic, right? So it's all real. The one thing that, first, let me just give a 30-second introduction of our company that will help me to just answer and get you the context. So we are an out-and-out technology platform company. So we are in the business for more than 7 years. And what we did is we built a platform which is basically taking all these different type of cognitive input from subject matter expert, maybe in different type of unstructured data, structured data. Example of the unstructured data could be the documents. Example of the structured data could be like enterprise data, enterprise metadata. Give it to that machine, and then machine autonomously learn and creates a causal relationship model. Just getting a little deeper into the technology. And this is Ron earlier mentioned that, so we are not solely relying on the correlation based model. Like A correlates to B, it's great. It's a good foundational step, but taking it to the next level, we need to know why A is moving B. So our platform takes the different type of knowledge input that I just mentioned, and then based on that creates a multi-dimensional causal network. So then that network aids all this orchestration of the downstream analytics activity.
So it kind of understands the cause and effect of what would cause this. If this is then what's the effect of that? Hopefully that answered, or at least part of it.
Other hands? Stand up.
Well, I have 3 questions actually, so maybe I'll just ask all 3. 1, when did you start at Georgia Pacific? 2 is, where have you taken like a fully automated approach versus the digital assistant approach? I hope that's meaningful if I say digital assistant, like Iron Man as a digital assistant maybe. And then what you were describing sounds great. Is there a way that we, as outsiders, could experience your system somehow?
Okay, your company?
I work for, I'm a operational excellence manager for Evonik. It's a chemical manufacturer.
Do you make paper?
No.
Okay. Do you make wood products?
No, but it's all different.
Just chemical. Okay.
It's all different. No, we don't make paper.
Okay.
I'm in their healthcare business line, so actually pharma CMO. I think we have a long way to go, but it's hard to help. It's hard for people to see what's possible. Sounds like you've had some success.
Let me tell you. So, what we actually, when you said your first question there, we actually kind of internally call this a digital business companion, right? Because we wanted to create something that our workforce could have that it's unlike a dashboard, because dashboards, some dashboards, you guys are good at it. You guys are great at it, and so are you. But some of the dashboards that you look at when you go into some of these control centers and stuff, it's like, oh my gosh, what is all of this, right? And it's like, well, yeah, so we have to look at this, and then we go look at this other thing, and we look at this other thing, and then we figure out what these things mean. And that's not what we wanted. We wanted something to figure that out for us, and then give us recommendations as to what to do. So if we have a question, it's like, what happens if a customer wants to change the number of days that they can send us an order instead of 5 days to 4 days? Well, what does that do to the supply chain? And this would tell, well, here's probably what it would do, number one, and number two or three. So it gives us optionality to ask questions and then give us an answer. To set it for fully automatic, we did do that in order management, in the supply chain part, just as a pilot, all right? We saw a 10-fold increase in the number of touchless orders that go through the system from the customer to the ERP. So that was a good step. What we're doing now is teaching it how to make paper. And so from a manufacturing standpoint, that's pretty doggone difficult, because there's a lot of moving parts in there, and there's a lot of chemistry, there's a lot of everything in there that can affect the base sheet that's coming off of the machine, right? The quality of the base sheet's got to be within this amount, because face it, everybody likes their toilet paper to feel like their toilet paper. You don't want it to feel like sandpaper, you don't want it to feel like other things, just like you get used to it. And that's the way you want it. So the machine's got to keep it that way. And so we're teaching it right now. I haven't done it yet, but that's what we're working on right now. Now, what you guys have done is an important step on, you've already figured that out. I don't need to go figure that out. I could just add yours to it.
And kind of building on the comment, give you an example from the chemical industry. And I won't name names because I don't have permission to, but needless to say, large company, about 13 sites in the U.S. and another 13 in Europe, and all large chemical complexes. So you're talking several hundred operators at each place. They've gone down a similar road in terms of capturing the experiential knowledge. They actually have a group called knowledge harvesting, the idea of capturing experiential knowledge. One of the things they've learned, because right now they're doing it all on paper-based, with the idea that it connects in. So they're creating the metadata that will allow them to tag into their various digital solutions. One of their big learnings early on was, naturally when we first started engaging SMEs, they're getting flooded with information. It was just all this different, trying to mine that experiential knowledge from an expert was just all of a sudden became too much. So they started selling on this concept of critical knowledge areas. So what do I really need to know from this person? What's not something I can get from just a book or from my basic training materials? What's truly expert-based experiential knowledge? And so as they're building the database, they're building that independently. So I'm very interested in what you all are doing. So they'd be able to connect into AI platforms or descriptive analytics platforms. So now they have a trigger that then connects back to the database to build. So they're different approach to them. Very interested in what you all are doing. But it's looking at the different tools to bring that experiential knowledge into real time, providing guidance around it. It's like a system like Canvas where it can look at the process data and say, here's how it's going to act. I can give you whether I'm predicting a failure or predicting process conditions, in providing guidance around that, then linking that to experiential knowledge. So, okay, if you encounter this, here's what you go look at. Here's what you think about. Here's how you start making decisions. Because some of these places you're not going to fully close the loop in some areas. You still want a person making that decision. So be able to link it into that experiential knowledge and provide guidance in the moment. It has huge value, particularly as we look at these retirement waves we're talking about over the next few years.
So go ahead. Roy.
Yeah. So one interesting metaphor that I can share with you. So as you said, like that's the way to go. Like just kind of blending these insights coming out from the data with this expert knowledge. So then you can deliver some insights which have never seen before. So so I live in Princeton. So Princeton is known for the physicists, right? So
Known for the what?
physicist.
Oh, physicist.
So so one of the best mind of our, I would say, 20th century, Richard Feynman. Richard Feynman, he was living there. So during the Challenger debacle, right, when the Challenger had that kind of accident, right? So NASA set up a investigation team. So that whole investigation team just kind of they've been trying to find out what caused this accident. So none of them just could find an answer. That explanation or excuse was to not have enough data. So the next day, Mr. Feynman, late in the evening, came with a paper and explained it. And that explanation was like the temperature on that launching date, or the ambient temperature was low. Because of that, the rubber gasket became brittle, and that caused this fuel leakage. So people asked him like, okay, how did you arrive at this conclusion? So Mr. Feynman said that, okay, so if you don't have the data, use your logic. So this is the same principle that we are following, and this is the way like how this analytics is shaping in future. And that's what Mike Carroll, like now he was mentioning in that keynote discussion. So now coming back to the ESG part, and we are privileged to work on the both sides. One, corporates like Georgia Pacific working closely with Ron and the team. The other side, we are working closely with the policymakers or the standard setters. So there we all
That's on the sustainability.
Sustainability.
So you're talking about the reporting for sustainability, right?
Right, reporting, and even before that reporting, that measurement. And I was just following Radik's your presentation, the way how you have been measuring these parameters, which are meaningful for that ESG assessment. That is going to be like quite critical, right, for that insight discovery. So that is phenomenal.
So we need to get you two guys together. I think is what needs to happen after the meeting.
I'm going to ask you a completely different question. One of my favorite quotes is from Enrico Fermi, who was a nuclear physicist. He said, if your data matches your hypothesis, you've made a measurement. If your data does not match your hypothesis, you've made a discovery. Tell me about some of your discoveries. Tell me about some of your surprises.
Do you want to answer this one
You want to
first?
think about it for a minute?
No, I was going to give him an opportunity.
Yeah, I mean, one thing we discovered, which I kind of identified, it was how to run our boilers, in a not set it and forget it way, but kind of base load, and intuitively it makes sense, right? Like run your most efficient boiler at the maximum, but being able to show it with kind of a statistical, proof, helps convince a team. I mean, one thing I find is with any kind of technical engineering people, like they want to understand like to the equation, right? You can't just tell them something, they believe it. You got to prove it. And then the other thing was how much influence weather has on boiler efficiency. Intuitively, this makes sense, right? Like more moist air is going to act differently than colder, more denser air and things like that, and your system should operate slightly differently based on those conditions.
A couple of things that we ran into, and we mentioned this yesterday. Was anybody in the room yesterday? So I don't want to talk. Oh, okay, a couple of people. Well, you get to hear it twice. All right. But when we were doing the first pilot for supply chain, we were looking to find out what would cause an order to not be able to be fulfilled 100% on time and in full, right? That's the goal, right? Create touchless orders. Whatever you're doing, you got to sell it, and to be able to sell it, you need to make it easy. You need to be the easiest company to do business with. And so that's what we were looking at. So what would cause this to not be 100% on time and in full? And so the machine came back, and it said that there's 26 reasons, and it calls them impedances, 26 impedances to keeping us from going 100% on time and in full. However, well, that's blew our minds. 26, I didn't even know there was that many problems. But it said, however, 5 of those are associated with all but 2. So if you solve these 5, then you've got almost everything covered, right? And so that was a huge discovery for us. And the only way that it would have known that is if it had the data, and then it had the knowledge of the people that actually do this for a living. And then the other thing on trying to teach you how to make paper, which is what we're doing now, which is terribly hard. But we found out that let's say you have a new supplier, and you want to see if this supplier will run through your process with their raw materials. And it's typically then what we would have to do is do a trial at our research facility. And then you have to close the mill down and run a mill trial. Anybody run mill trials before, your facility trials? You can't do it in the nuclear facility back there. We don't want that to happen. But it's a big deal because you're not making sellable paper at that point in time, and it's a lot of money. So you don't want to do that. But what we taught it was to be a digital twin of that. And so it brings the measurements in of the fibers and whatever, or the chemicals in your case, and says, okay, this could probably work in 5 of the 22 mills that are making tissue, right? Or 7 of the mills, or 18, right? And so that was a pretty big discovery for us. That we still need to redo the trial, but this gives the operators, it gives the leadership in the trial of the mill itself a little more confidence. You know, it's like the first time that you used Waze, you thought it was a liar, right? Anybody, right? But the more you use Waze, you go like, well, doggone, it's pretty good. It beats me every time.
Yeah, the point of Enrico Fermi's quote was, embrace the discoveries. And you guys learned a lot. That's great.
Yeah.
So it starts with a denial, then discovery, then surprise.
I want to build on Radek's point and Ron's as well for a second. It's one of the things that we find a lot of people are approaching AI from a perspective of kind of the pot of gold at the end of the rainbow of how do I get everything to be predictive? How do I move to condition-based maintenance? All the things that the AI promises. And the problems that they're running into is they're starting, in my opinion, too big. They're creating huge organizational problems associated with it. And beyond that, they're creating big data problems. Because now as I've expanded the problem with this idea of AI can do all these great things, which it can. AI loves data. But you've now created an organizational problem for yourselves. And something that Radek made a comment in his presentation is it doesn't always have to be the full solution. It doesn't always have to be predictive to start with. A chief digital officer friend of mine said, you know what, if AI can get my engineers 50% of the way, if they can get them 50% so that now they can focus on what I want my engineers to do, not going collecting data, not sorting through everything, but if I can get them focused on the real problem, to me, that's a huge win. The insights I get from that. And I started my career as a unit engineer making nonwoven, so I actually made the material that goes into all this surgical face masks, which is printing money. when those things are running. And that is, your raw material costs that go into surgical masks are nothing. And you're selling a medical grade product, so you're printing money. And one of the kind of stories as a unit engineer that always stuck with me is we spent 3 months troubleshooting a problem after we did a big retrofit of the unit. And eventually went back to square one and started going, what are all the things we know? And had an operator in the back said, well, we always have this particular issue. It's a tensile strength issue, at this time of the year. So it's North Carolina in the summer. And at one point, got all interested. Well, okay, that's interesting. Well, why? And we eventually got back to its humidity in the air, which changed the heat capacity of the air, which changed the quench rate of the pollen, which changed tensile strength. Kind of the long story short. But the point behind all this, and this is where AI comes in, it takes an unbiased look at the data. As experienced engineers, we were all discounting that because that had never been a problem for us in the past. It never got to the point while the tensile strength changed seasonally, it never got to the point of being an unsellable product. And I go back to my chief digital officer friend, he said, look, one of the great things about AI is it takes an unbiased look. And if it just gives my engineers insights and take that example, to point them in the direction of, hey, you need to look at this ambient condition because I don't know if it's a problem, but it's a contributing factor. Now smart engineers go, okay, what happens? Why do I care about it being summer for a non-woven? Well, I care about now I start then troubleshooting back out. And then if I can bleed in, start bringing in experiential knowledge, now I start to be able to connect that, say, okay, this is what you go look at. Here's what you consider. And so when you start thinking about AI solutions, and I think this was really good about Radix pieces, while you want your vision in mind, don't discount those small steps along the way. The low-hanging fruit, as Radix said. The things.
80-20 rule.
Yep.
Yeah,
If you captured 80% of it,
Yep.
move on.
Yep.
Because there's so many other low-hanging fruits to tackle.
Especially if you're just getting started on the journey of transformation. You might not want to start with what we're talking about here, but if you've been on that journey for a while, then this is something that you can look at, because automation was the thing that we had to look at first. We have to manufacture product, and with 45% of your employees evaporating into retirement, right? Then, I mean, that's a lot.
Yeah, I mean, I think take the Moneyball approach, right? Of get on base, hit singles, maybe a few doubles, right? Don't try to go for home runs because your team will get fatigued, right? And that's what the CEO wants. He wants home runs and stuff. But Moneyball approach, if you can kind of take that, I think the probability of success is much higher.
But Radic also, I would think this too. It gives you the opportunity to build in the sustainability that you have to do. We all having to do it. You're not going to get away from it, right? And we need to do it. It's the right thing to do. But this is the perfect opportunity. I mean, you've got a whiteboard that you can start chipping away at little problems and making more sustainable decisions as we go along.
And just because we're talking about sustainability, being on the kind of the last point on to the Radix side of this as well, is if you start thinking about small problems, if you have an end vision of where you're going, so you take a boiler example around it, and have longer discussions why you pick on that one. But as you pick that first place of just load balancing from a fuel gas standpoint, once you have that from a base AI, I can layer in other data sets. And again, because AI takes an unbiased look at the data, sometimes it will point you in directions of, I didn't know that was interesting before, but now I recognize I need to see what's impacting this, so I bring in the data sets of the things that impact that variable. And I can start layering in, go from just fuel gas deficiency to a water balancing, into water chemistry. I can bring that into greenhouse gases. I can bring that into production. So that's the great thing about AI, is it has the ability to layer in data, but don't start with all the layers. Don't start with trying to make a really complex problem. Break it down into pieces, because it'll be easier for your people to start there and to get their heads around where they want to go.
Just one more thing I would add about kind of models and AI is that, make sure that your models are, for lack of a better word, open and available. So one model is not stuck in a certain platform. For example, we want to be able to pass Canvas's prediction to a control system, but maybe also to another model, right? And I mean, what makes it easy is like, the internet is basically built on open standards. So you just leverage that framework to, to pass things onto each other. And I think like a plant would be a combination of models typically, so.
So one more thing that sorry.
No, I was looking for hands in the audience.
Yeah.
Go ahead. Shelley, go ahead.
Yes. I'm a bit of a plant. I work for Georgia Pacific. The question's really addressed to Radik and gentleman from Parable, Rajiv. ESG, talking about ESG and all that's going on from a regulatory and changing and multiple standards, et cetera. What are the key challenges and how, and you've got a lot of experience here, Rajiv, in terms of doing a lot of this for different people. How are companies coping with generating the right data at the right time, the quality, and adhering to the new standards that are emerging, and doing this in, at the speeds required in a digital way that makes sense?
Isn't that the problem? The standards? It's that they keep
Standards,
popping up and changing, and it depends on what
Right.
you're looking at to be what standards you're going to adhere to.
So interesting question, Shelly. So we are getting into a completely different business environment. So post COP26 summit, which happened in Glasgow, so everybody realized that just we are getting into a very different collaborative environment, which we might not have seen before, like where business entities, private, public, and the policymakers, regulators, everybody is collaborating with each other in terms of exchanging sustainability data, right? So now the challenge is like, whether it is adding more problem to our daily task list. The answer is yes. So we as a company, see, one side we work with corporate like Georgia Pacific. The other side we work with these policymakers and the standard setters globally. So one big challenge that all the policymakers are facing today, that there are number of different standards in the ESG space. So you won't believe it, like probably all of you might have seen that it is nothing less than 40 plus standards, and each standard is coming up with at least 100 plus metrics. So now to make it understandable by the corporate, it's a hard task. So now standard setters are talking in their language, corporates are talking in their language. So there is no harmonization. So the first challenge is to kind of build a consistent language that we all are talking about. That's number one. And number two, from the corporate side, another transformation which is taking place in terms of that workforce. So earlier, most of the times that data which the systems have been producing were produced for human consumption. So now we are moving from human workforce to a hybrid workforce, where man and machine both are going to take part in the decision making. So whatever the data that we are producing need to be equally consumable by the man and machine. So what we need, from the policymaker standpoint, they realized and they come to a consensus that we need a common language, which is a digital taxonomy. So if we have the digital taxonomy, which represents all the different standards from the different jurisdiction, and if we can enable corporates to connect to these taxonomies with their internal taxonomies, then probably we can share the same data seamlessly across that ecosystem.
Other questions from the audience? Follow up.
Yeah, I'm actually going back to the last conversation. I agree with you in that this big change happens in small steps. At Ingredion, you gave a nice example, but I'm curious how much bigger the initiative is than what you described. Are you running 10 at a time? Have you done just the one? Have you found a way to kind of scale this up and kind of like experiment, build the infrastructure, that kind of a thing?
Yeah, I mean, it's a good question. So, I mean, today in 2022, we have a big like our CEO has said, we must deliver $100 million of value from digital transformation projects. So, that's a public kind of facing statement. So we have this started back in like 2017, which was like, one guy doing this, but now we have a kind of a digital organization, our CIO is our chief digital officer, and like there's now this whole org structure behind it, and additional, finance, marketing. We have this kind of digital leadership kind of council, and we present opportunities. Manufacturing is probably the biggest kind of chunk of that, probably, $60 million of that $100 million target. And it's kind of iterating through, these kind of classes of problems: reliability, energy management, yield. Basically we start with where are the biggest costs and look for opportunities there. So, corn is our biggest cost, so yield is a big thing. Energy is our second biggest cost, so, energy management is a big thing. Maintenance is typically like one of the big items at a plant, so, reliability. So,
Radek, I got a question for you.
Yeah.
So one of the questions that I get a lot, and I don't know if you've heard it, but it's similar to what you just asked, is, so we've been doing this for a while, just like, we were 2015, you're 2017, so we've been going at it for a while, but if they're just starting, if you're just starting and you want to get something done, let's say that you're the vice president of the mill, right? And you're in charge of the mill. And so you own this asset, and you own the digital copy of that asset. And so you say, you know what, I got an idea. I want to go check this out, right? So, but now you have to go to IT and you have to ask permission. This is what the question, right? So because they say, you know what, if I want to do something, I got to go ask permission to do it. And then they say, well, I'll get back to you.
So,
right?
so ask for forgiveness, not permission. Like,
Right? That right? So, but they come back and then they say, well, yeah, you can do that, but you have to give me permission to hire somebody to help you get it done, and to hire somebody to sustain it, right? So anytime that you want to do something, there's more cost, and it scares some of the people, so such that they go back to their leadership and they'll say, yeah, I can try this, but IT says it's going to cost, $275,000, per year for me to go try this, and it stops them.
Mm-hmm. Yeah.
It stops them, and that's what you have to try to overcome. You have to try to overcome that hesitancy to spend a little bit to get the benefit of $100 million or a whole lot more.
Yeah. I mean, you start, I think, at a small regional level, like at a plant, try to get your plant management team on that. If you need some like infrastructure, the first way we did it is we literally like hacked it together. So we didn't have Azure Data Factory and like the right rails. Like we were just exporting some data points using FTP, to Canvas, and then, 2018 we got onto Microsoft Azure, which, very useful platform. Same with like AWS, right? So, but once you have those tools, like then you don't really need IT, right?
Yeah.
You need them to.
They're in the job for the infrastructure.
Yeah, as
Right?
long as
It's like
there's
holding
some
up your
infrastructure,
phone.
that then you can do a lot of it.
It's like holding up your iPhone.
Yeah, exactly.
That's what they do.
And to give you another example of your question, this is a oil sands company, so a little bit larger operations. And when they started with a team of small team of data scientists, 5-6 problems, going after their most complex problems. And the problem they ran into is they couldn't get any traction. The sites didn't want them there. Sites didn't want to participate. They didn't want to give them data because they weren't adding value. They were trying to solve these very complex problems, spending lots of time doing it. And this is coming from their EVP of oil sands operations. He said, when we stepped back and said, look, let's go after the small problems, go after the things that are causing issues at the plant site. And they started with small assets. They go after compressors or pumps. And this is oil sand, so nobody wants to go outside. So in the winter, if I can keep people from go outside, I got people lined up out the door. They're saying, I'm on board with that solution. So they started with very small assets, and then said, once we start with that approach, we went from a team of 5 data scientists and people looking at this to a team of 100. over the course of a year because we started those small discrete problems, and all of a sudden we created pull from all the different sites. And now instead of it's just a push, and I'm really trying to convince you I can go solve these great problems for you, it became, hey, wait a second, can you help us with this? Can you help us with that? And so they grew from there. Like I said, that's when they really got traction. They started adding value in a meaningful way to the day-to-day business.
Yeah, you cannot push anything onto a plant, right? Like you need to create pull because it'll fail if you try to push.
They'll tell you to go pound sand.
Yep.
Yep.
You had a question.
No, Rajiv is trying very hard to make a comment.
Oh,
No, important thing is like particularly coming back to that ESG. So it's very hard to just make a business case for manufacturing companies. Say, for an example, so most of the manufacturing companies made a quite a few $1 billion investment in that machines, right? So now if we say that, okay, you have to just make another $1 billion investment, or you have to just start changing your machineries bottom up, it does not add up to the business case. So why should I reject my existing mill and make another investment to just make it ESG compliant? But interesting thing that can happen, like it means if we become more creative to take the parts of that machine, change it. For an example, Radik, like what you have we have been showing, like the measurement. So earlier your measurement was through a different sensors, say analog sensors. You change it to that digital sensor, like which will give you a better efficiency, and maybe it will help you to increase that ESG efficiency as well. So in that way, so you don't have to make an investment of multiple $1 billion for changing that whole assembly line or the mill. Rather, making a kind of fractional investment, get that benefit and feedback that benefit into that kind of next wave of development.
I know we're out of time, but is there a quick question?
he's been trying to in the back.
Please, stand up, company name and all that.
Keith Lighting, Sunoco Metal Packaging. I just have a
Did you
question.
say packaging? Okay. I just wanted to be sure.
We use paper. We don't make it. So I liked your quote, Ron, that you said, or automation isn't job replacement. It's a response to job vacancy. I've always thought of it as you're replacing an unskilled job with a skilled job because you have to have someone to maintain it. But I like that. I'm gonna steal it if you don't mind. But going along with that, I'm just, as far as the AI goes, what do you have to do to maintain it? How often do you have to maintain it? I know there's some things like kind of what you were talking about yesterday, where it asks if is this correct? Did I make the right decision? And you can say
Yeah,
yes or no,
it
basically.
continuously learns itself. Once you teach it, it has a continuous learning loop where from feedback and it checks itself to make sure that was it this really the right decision? After it's made the decision, it'll go through almost like a digital twin of itself to check itself. But to your question of how often do we have to sustain it is although it's ours, right? And I'm not really trying to sell it or anything. I just want everybody to be aware that this is able to be done. It's a software license, and so we pay Rajiv to just like you get paid to maintain it, to continue with updates, to make it better. Because if we can do this now, imagine 7 years from now, 5 years from now, it's really going to be.
Yeah, I don't want
Really
to maintain
cool.
models. Like I just want to pay him 20 cents to save a dollar.
We got enough to
basically.
do.
Yeah.
So are you making Are you making monthly payments, annual payments? Are they almost on retainer basically for you guys?
It's just, for us, it's an annual subscription
Yeah.
basically.
And then I had another question, just on your boilers. When you were training them with models, I saw that you put them each on their own model. Are you training them with multiple models at the same time to try to figure out which model you actually want to go with, kind of thing?
Yeah. So this is probably Canvas's kind of a platform, right? Is they run? So we send them historical data at a very kind of narrow resolution, and they run it systematically through dozens of algorithms, and then it ranks what is the most accurate or best predictor, and then we put the best one into deployment. So in this case, I think it's a neural network that is the most accurate. So one of these black boxes, right? So again, we don't care to know like what's happening in that model as long as it's giving benefit. We did go through an exercise of, okay, like, so what is happening? So then we just went to the second best model, which was like a general linear model, GLM, which actually does give you the weightings of the coefficients. So you can kind of use, maybe the next best model as your kind of light box, right, to see what's happening, but then use your black box model in production because you want the best prediction, right? So you can kind of, so you can use combination models. Yeah.
Okay. Thank you for staying late. And I'd like to thank the folks on stage for sharing their knowledge. That's what this conference is all about.